Hello everyone. So we are going to get the derivative of this function. So as you can see, this function is, let's just say, simplified because this function is already in factored form. So this so-called factored form results into two polynomials separated together. So we have this polynomial. Okay, we can just describe this as a binomial because it has two terms. Then we have this polynomial which we call as the trinomial, which involves three terms. Okay, as you can see, we have x squared, 2x, and negative 3. So there are three terms in total. And for this case, we only have two, for x and negative 1. So in this case, we're going to use two methods, all right, in terms of discussing this one. So the first method is, just like in the previous video, expansion before differentiation. All right, you can still expand this one. All right, then after that, differentiate it. Then the second method is you're going to use what we so-called the product rule. Okay, so let's start first with the first one, which is basically expansion before differentiation. So how do we expand two polynomials that they are not the same in terms of the number of the terms? Because as you can see, we have a polynomial and we have a trinomial. If this is polynomial, if this is a binomial, then we can just use FOIL method. However, as you can see, this is not a binomial. Rather, it is a trinomial. So, what are we going to do? So, we're going to manually expand them. Okay. So, how can we do that? So, right, we have 4x minus 1. And then we have x cubed plus 2x minus 3. So, what we're going to do is simply, um, let's start with this one. We're going to distribute this term to each of the terms on the other polynomial. Okay. Then we're going to do the same thing here for the next term. We're going to distribute this term to the other terms on the other polynomial. Then after that, we're going to combine them in terms of similar terms. Okay? So we're going to take it slow so that you will understand. Okay? So basically distribution, then combining of similar terms. That. Okay. So let's start. Let's distribute 4x to these terms. So 4x times, wait, this is supposed to be 2. I'm sorry. Sorry guys, this is supposed to be 2. There you go. So 4 times x squared will give you 4x cubed. Next, 4x times 2x will give you 8x squared. Then lastly, 4x times negative 3 will give you negative 12. Okay, that's it. Next, we're going to proceed to this term, which is negative 1. There we go. Okay, so if you proceed to the next term, okay, since obviously you're going to multiply these terms by simple distribution, you're going to start from here. Okay, you're going to start at the second place, or basically where the second term is placed here, which is your 8x squared. Okay, so we're going to start at this place. So negative 1 times x squared will give you negative x squared. Next, negative 1 times positive 2x will give you negative 2x. Alright? Then lastly, negative 1 times negative 3 will give you positive 3. Then, after we distribute each of these terms to each of the terms on the other polynomial, we can now combine them together. So here, we're going to bring down 4x cubed. Next here, 8x squared minus x squared will give you positive 7x squared. Then here, negative 12x minus 2 will give you negative 14x. Then lastly, we're going to bring down positive 3. And this is the expanded form of this, uh, this given function. Okay? So we can rewrite this as the derivative of 4x cubed plus 7x squared minus, wait, minus 14x. Wait, let me rewrite this one in a proper way. Okay, so this is negative 14x, then plus 3. That's it. Okay, so I'm going to erase this one, right? Because maybe I'm going to occupy this space. Okay, so yeah, I'm going to erase this one. All right, let's go here. So now that this function is already expanded, you can now get the derivative for this expanded form of a function. So first, let's start what we observe here. So as you can see, we have x cubed and x squared. All right. So this means that this term has a variable in which it also has an exponent. Therefore, we are going to use power rule of differentiation. Okay. There you go. X raised to 1. Okay. So basically, in this case, okay, if we have a variable that has an exponent, just simply bring down the exponent, copy the variable, and then and then the exponent above you used to bring down will be subtracted by 1. That's it. Okay. Next, we observe that we have a simple x. Okay. When we say simple x, meaning the x has an exponent of 1. Or basically, yeah, the one you just saw. Basically, it is just a simple x. There is no exponent that is greater than 1 or less than 1. Just simple as x. So you can either use this method, which is power rule of differentiation, or you can just use this method, okay, which is basically the derivative of cx, okay, where the c is a constant and x is just a variable, all right, and plus the x here has an exponent of 1. So you can use this method to this one, okay, you can. So the derivative of cx will just give you c, okay, that's it. So basically the coefficient of x, all right. And lastly, we have a constant term of 3. So we're going to apply that with the constant rule of differentiation, which is c, all right, the derivative of c. So the derivative of c, or the derivative of a constant term, will give you exactly 0. Okay, so let's now differentiate this expanded form of a given function. So here we have 4x cubed. So again, as you can see, this x has an exponent of 3. So we're going to use this one. Okay, this is what we call as the power rule of differentiation. So in terms of the coefficient, which is 4, we are not going to touch it yet. So leave 4b. All right, leave it b for a moment. Then let's get the derivative of x raised to 3. So for this one, just simply bring down the exponent, copy the variable, and then the exponent, which is your 3, okay, the exponent you used to bring down will be subtracted by 1. That's it. Next, For the second term, it's just the same way we did on the first term. Okay, just leave the coefficient b. Don't touch the coefficient. Then here, okay, just bring down the exponent, copy the variable, and then the exponent above you used to bring down here will be subtracted by 1. Okay. Now next, we have negative 14x. So as you can see, you can either use this method, which is power rule differentiation, or you can use this method, which is basically the derivative of cx, or basically derivative of simple x. Yeah. So here, I'm going to apply this rule to this one, to negative 14x. So the derivative of cx is c, or the coefficient of x. Therefore, the derivative of 14x is just 14. That's it. Then lastly, we have a constant term of 3. So if you're going to get the derivative of 3, it will result to 0 because 3 is a constant term. Hence, the answer for that is just 0. Okay, so now we can now simplify. Okay, so 4 times 3 is 12. Then the exponent above 3 minus 1, it will give you 2. Next, 7 times 2 will give you 14. Okay. Then, yeah, variable x. 2 minus 1 will just give you 1 or just simple as 14x. Okay. Then, lastly, copy negative 14. Okay. Okay. So, this could be your final answer. However, if you want to simplify things, then it's okay. So, as you can see, there is a GCF. Okay, GCF of these expression. These terms, 12x squared, 14x minus 14 has these terms, 12x squared, 14x, and negative 14 are all divisible by 2. Okay? These terms, once again, okay, are all divisible by 2. So we can just factor this expression by 2. So this would be 2 times quantity cx squared plus 7x minus 7. So this could be your final answer. All right. If you think that this what I call this one, this what I call this one, trinomial here, 6x squared plus 7x minus 7 is factorable, then you can. There is no problem with that. You can factor this one if and only if it is factorable. If not, then leave it be as it is. For it is impossible to factor out this one. Okay? So, that's for the first method. Now, for the second method, we have what we call as the product rule of differentiation. Okay? So, for the product rule of differentiation, all you need to memorize is these letters, U and V. Okay? U and V. All right? And if you get the derivative of U, it will give you du. And if you get the derivative of V, it will give you dV. Okay? So, to sum it up, the formula of product rule is basically U times dV plus V times du. That's it. Okay? Again, U times dV plus V times du. Okay? Or basically just try to memorize this one by saying it out loud. U dV, V du. U dV, V du. That's it. Okay? So, um, let me rewrite it properly. U times dV plus V times du. So, which one is your U and which one is your V? It's up to you. All right. For me, my U here is 4x minus 1. And my v here is x squared plus 2x minus 2. Okay, that's it. So u is equal to 4x minus 1. Okay, now we're going to get the derivative of your u, or the derivative of 4x minus 1. So how can we get the derivative for this one, if you guys recall? So for 4x, all right, simple, we're going to use the derivative of power rule, or cx, right? Okay, cx. The derivative of cx is equal to c. So here, the derivative of 4x will give you 4. Okay. Then next, for a constant term, which is negative 1, just use this rule. Okay. The derivative of a constant term, okay, the answer for that will just be 0. So that means the derivative of negative 1 is just 0. So we have 4 as a result. That's it. Okay. Next, for v. Your v here is x squared. Oops, hold on. Let me fix that. Okay. So x squared plus 2x minus 3. So let's get the derivative of your v. So right, we have x squared here. So as you can see, this one, it has a variable in which it also has an exponent. So we're going to use the power rule of differentiation. So x raised to n. Okay. So basically, just bring down the exponent, copy the variable, and then the exponent above you used to bring down will be subtracted by 1. Okay? So we're going to apply this rule to this one, to x squared. Okay? So let's bring down the exponent, copy the variable, and then the exponent above you used to bring down will be subtracted by 1. Or just simply memorize this formula if you don't want me to say it again. Okay? Next, we have 2x. So as you can see, 2x, okay, we can use this one or this one. It's up to you. But for me, I'm just going to use this one. Okay, the derivative of cx is equal to the c. So therefore, the derivative of 2x will just be equal to as 2. And lastly, the derivative of negative 3, which is your constant term, will be just equal to 0. So we have 2x plus 2. All right. So you can use this one, but if you want to use it in simplified version of it, you can. All right. The GCF of this expression, which is 2x plus 2, is 2. Because both of these terms, 2x and 2, are both divisible by 2. Hence, I can simply rewrite this as 2 times quantity x plus 1. There you go. All right. So now that we have u, v, du, and dv, we can now substitute it here in this formula. So before anything else, I'm going to erase this one. All right. Because since we already applied differentiation here, so what we're just going to do here is just simple as distribution and simplification. Okay. So let me erase this one because I'm going to use this space for solutions. Okay. So rewrite this one. This would be u times dv plus v times d. Okay. So your u here is 4x minus 1 times your dv, which is here. So this is, whoa, hold on. Wait. which is 2 times x plus 1. All right. Next, we have your v, which is x squared. Wait, hold on. X squared plus 2x minus 3 times your du is just simple as 4. Okay, that's it. So now what we're going to do here, just like what I mentioned earlier, is we're going to simply distribute. All right. But first, let me rearrange. This constant term 2, I'm just going to put it on the first place. And same thing here for the 4, I'm going to put it on the first place as well. So hence, I will have 2 times quantity 4x minus 1 times quantity x plus 1. There we go. All right, plus 4 times quantity x squared plus 2x minus 3. That's uh, so we're going to, I mean, you can leave this as your final answer, but in most cases, you really need to simplify this one aside from substitution only. Okay? So what we're going to do is we're going to sorry, what we're going to do here is we're going to expand this one. Okay, let's expand these binomials, 4x minus 1 and x plus 1. So we're going to apply FOIL method. So this would be 2 times, okay. So FOIL method, okay, first terms, we're going to multiply them. 4x times x squared will give you 4x squared. Next, for the outer terms, we're going to multiply 4x and 1. So this would be just 4x. Next, for the inner terms, we're going to multiply negative 1 and x. So this would be negative x. And lastly, we're going to multiply negative 1 to 1 or multiply the last term. So this would be negative 1. There you go. All right. So let's copy the rest. 4 times x squared plus 2x minus 3. So we're going to, combine similar terms here. 4x minus x will give you 3x minus 1. All right. Then plus 4 times x squared plus 2x minus 3. Okay. So after that, we're now going to distribute these terms to their what do you call this one? To their corresponding polynomial. So 2 times 4x squared will give you 8x squared. 2 times 3x will give you 6x. And lastly, 2 times negative 1 will give you negative 2. Plus, here, the same thing. 4 times x squared will give you 4x squared. 4 times 2x will give you 8x. And lastly, 4 times negative 3 will give you negative 12. Okay, so now we're done at distributing. Now we can combine similar terms. First, I'll combine 8x squared and 4x squared because both of these terms are similar because of their variable. Because their variables are x squared. So we can combine them. So 8x squared plus 4x squared will give you 12x squared. Next, 6x times, 6x plus 8x, we're going to combine them because 6x and 8x are similar due to their variable, which is x. So 6x plus 8x will give you 14x. And lastly, negative 2 minus 12, we're going to combine them together because both of them are similar due to their constant terms. I mean to say, both of them are similar because both of them are constant terms. So when we say constant terms, meaning they are just numbers. There's no variable involved, just numbers. Hence, we're going to combine them and the result would be negative 14, which is the same as what we had before, you know. So we can now simplify this one by factoring. The GCF of this polynomial is simply 2 because these terms, 12x squared, 14x, and negative 14, as I mentioned earlier, are all divisible by 2. So this would be 2 times quantity 6x squared plus 7x minus 10. Oh, so this is your final answer. See? So it's up to you guys. All right. So it's up to you. You can just use the first method, expansion, or you can just simply use product rule. It's on your choice. Okay?